Hello, everyone. Thanks for joining our new webinar. So I hope you can hear me good, and we will start in a couple of seconds. So thank you for joining us today, and I hope you will find it interesting. And so let's start with our webinar, and here we go. So the topic for today will be film-forming amines in practice with focus on boil-out and steam blowing procedures. And we are going to start with the presentation. And yeah, as I said, topic for today is boil-out and steam blowing. So I will start with a short introduction in that topic and give some application guidelines about the use of film-forming amines in this specific topic. And at the end, I will show you a few case studies where we have done these procedures in several sites. So let's start with the first point. So film-forming amines can be used in very different ways. So, of course, the most common principle is the continuous dosing, but there are some special applications on the market. A few of them we have already covered in the previous webinars last year and also at the beginning of this year. So we spoke already about plant flexibilization. So how can FFAs help to improve the flexibility of flexible operating power stations. We have already spoken about preservation procedures and layup and how FFAs can contribute to that. And today we are going to look at boil-out and steam blowing procedures. And just some short remarks on that. So new boilers, when they arrive at site or build up on site, they often have a internal corrosion going on, which is rust and iron oxides, also some residues from the manufacturing processes, and there are oil and greases inside, sometimes also a sand. So, and all these coming from the manufacturing process, maybe storage on site or long-term transportation if you ship them over a long way. So boil-out procedures are a common pre-commissioning procedures to clean the water contacting surfaces, especially in the boiler. And they are in difference to the acid cleaning. They have a less risk of attacking the metal, and also they have a higher cleaning effect on organic contaminants in the boiler. For systems operating on later with a steam turbine, they often request steam blowing afterwards, and this is used or this is done by using a high velocity steam just to remove loose particles, oxides from the steam lines to protect the steam turbine from damage during the startup of the plant. Most common, these boil-out procedures were done with a strong alkaline solution. So it's an alkaline boil-out procedure, and but due to ongoing stricter regulations on discharge, there is a need for more environmental friendly and also easier to handle alternatives to do those boil-outs, and that's why the film-forming amines especially play an increasingly important role in this field. Why are they helpful, or why are they looked at? So, of course, or the first thing is they also have a strong cleaning effect, and this even with a neutral pH value. So if you remember the previous presentations and webinars, you have seen that these filming amines are able to remove loose iron oxides from the surface, And this is also, they are a good surfactant against oil and grease. And if you can do this at a neutral pH value, you don't need to treat the drained wastewater to do a neutralization with an acid. And so this improves the safety and the handling and also the application time. Second big advantage is that during the cleaning process, there is already a protective layer formed, which these film-forming amines do as usual. And so there's a really good corrosion protection, even if the plant is not commissioned to the end. So if there's any delays and any waiting time after the boil out until the plant starts full operation. And so there's a very effective corrosion protection in that time so that no further oxide particles are moved to the steam turbine when starting up the system. Also, the filming amines are steam volatile. So if you produce a little bit of steam during the boil out process, you can open your steam valves, let them enter the steam lines. And also there, the amines adsorb at the surface and form the protective layer. And this causes less particle erosion when doing the blowdown procedures. So normally you need much less blowing procedures to have the same steam quality compared to an alkaline boil out. All this leads to a reduced time for the cleaning process, so you can reach the target limits much faster, and this also has an effect on the energy and water consumption. So you use less energy to heat up the plant, you use less water for draining and cleaning, which is a very effective and economic way of boiling out. And also most of the FFAs are biodegradable, and they are environmentally friendly and phosphate free. So they can be drained into the dumpers on site or in the sewage treatment plant, so that it is a very safe operation. And also you can substitute the use of dangerous goods like acids and high alkalinity solutions. Starting with some application guidelines. So I will start with some general requirements and then looking on the best practices with film-forming amines. At the beginning, when you start thinking about boiling out a system, you should think about some questions before you start. For example, where's the water coming from? So you need a sufficient amount of water. Normally you need demineralized water. So you have to check if your water treatment plant is already in operation, or do you need a different source to get the water in the right quality in the amount which is necessary. Also, when you think about heating the system, maybe you need an external burner to do this, or where you also need a fuel supply and storage on site. So you have to take this into account as well. And another thing is the sampling lines and the analytic panels. So if you have already installed your online monitoring systems, you should avoid that water with a high concentration of iron and debris and whatever comes from the system is entering to your analyzer systems, because they don't want to have that. And after the cleaning, so you need to drain the water somewhere. So are there any restrictions on the water quality, on impurities, on temperature maybe? Where can you drain it? Do you need to do a neutralization afterwards? So this also needs to be taken into account. And the next thing is you need to do inject chemicals anyway. So you need to find a good point where you can inject it with a good distribution. You need the sufficient dosing pumps, place for chemical storage. If you're going for a steam blowing, you need a bypass system for the steam. And you maybe also have to look on environmental impact or noise. So there will be regulations on that has to be controlled. And also how to control the process. So you need a control plate for the steam blowing, how do you rate the cleanness of the boiler. So there are a lot of things taken into account. So this is not an exclusive list. So there are more and more things to consider. So it's important to make a good plan with writing down the procedures, the chemicals, and the time schedule, or you get one from your boiler manufacturer. So you should look at, is there anything which need to covered additionally, which is not mentioned there. One good standard is the VGB S513. So it was already published in 2000 and in 2000, and now there is a revision available. And this guideline covers not only the boil out and the steam blowing, it also gives information about flushing and acid cleaning. So it helps to plan these activities for new plants or for repairs or during operational maintenance. And it's a very good guideline to avoid risks for the systems, because they have been reported a lot during the years before, where there were also only non-standardized procedures available. And of course, a proper cleaning has a direct effect on the water quality or the water steam quality, and also on the economic efficiency of the plant. So if you start up the plant with a clean boiler, you get less issues during startup and can run the plant safely. Now I've listed some steps which we were doing when we do a boil out with the film-forming amines. Of course, you need to flush the boiler first before you start anything, because this will remove all the loose particles, sand from sandblasting, and sometimes there are even tools inside. So do a proper flushing of the boiler. This will secure the integrity of the system very much. Of course, this doesn't need to be done with demineralized water. You can use a tap water, for example, just to flush the boiler and drain it afterwards to remove the larger particles. And then you starting the boil out. So you fill the boiler mostly with cold demineralized water. In some cases, and where it's available, you can also use preheated feed water, because this reduces the heat up time for the boiler. Also, you can add already some chemicals to the feed water tank, but normally you use a cold water. So you raise up to the minimum water level of the boiler, and then you start heating up. Mostly you have a guideline from the boiler manufacturer to also dry the refractory linings inside. So you ramp up the temperature, and then you hold it for several hours, and then you ramp up again to the next level. And so this is also to avoid thermal stress to the boiler, to sufficient heat up. And so if you have those guidelines, follow them, and will work perfectly. There's nothing, so if it's not a new boiler, it's a used boiler, or any other like a boil out after a major revision of the plant, you can also run to a temperature of about 150 degrees Celsius. And this should be kept for about 8 to 12 hours, depending on the boiler size and circulation. So this will give you a good distribution inside the boiler. And if you have reached a temperature of 60 degrees Celsius, you can start feeding the FFA into the boiler directly in the boiler drum, or in a collecting pipe somewhere where we have a good distribution, where it cycles around through the system. And so you should not add below 60 degrees, because then you can get a local issues with overfeeding. So because of the temperature saturation point, it's better to start at higher temperatures. And slow by slow, increase the concentration in the boiler water. So the maximum concentration we use is 1.5 to 2 ppm. Active free concentration in the boiler water. To the end of the boiler procedure, you should increase the water level inside of the boiler to the maximum level you can, and also a little bit overfill the boiler just to make sure all surfaces are touched with water to have a good absorption and cleaning effect. And to keep the concentration stable during this water level increase, you will have to do a follow-up dosing with the FFA to make sure the concentration stays in that range. This is the measured concentration. So you take a sample from the boiler water, and then you can measure the FFA concentration, and it should be in that field of this limit. If you keep the steam valves open when you do the boil out, you have already a distribution of the steam to the steam pipes, and with the steam, also the FFA is entering in these steam pipes, condenses on the steam pipe surface, and also there first layer is formed, and this helps to do during the blowdown, during the steam blowing later, to avoid too strong mobilization of oxides from the steam piping. After these 8 to 12 hours, you drain the boiler, cool it down, and drain as hot as possible. And then you check for particles in the blowdown or the drain water. You can use a turbidity meter or filters, or do iron monitoring with sampling. So just check that the concentration, how the boiler water looks like, and that the iron concentration or TOC is not too high. And then you repeat the steps at least once, of course without the flushing, but this boil out procedure until your boiler water is free of particles. So normally it's fine after the second boil out, but in some cases when it's very, very dirty, it might be a third necessary, but so far we did not see that in our history. Coming from that, I will give you a few case studies which we have done, or which we have done with our partners. The first one is from a hospital center in New Zealand, where we did the boiler together with our local partner company, Vicentia. And it's 3 low pressure boilers with a total steam flow of nearly 23 cubic meter per hour. The expect makeup water is softened, so they start with a pre-service cleaning of the condensate, feed water, and boiler, and then it was planned to keep the ODA and trisodium phosphate as treatment in service. You see it already on the picture, so there are different boiler manufacturers. And you will also see in the coming pictures that there is quite a big difference between the boiler manufacturers and the inside stage. So during the pre-commissioning cleaning, we had the first phase where we were dosing ODA with a concentration of 1 to 2 ppm. Here we had already the feed water in operation because there was an existing boiler plant as well, so we could use the feed water. And then the system was drained and refilled with a lower concentration, and then inspected again. You can already see some nice water repellency pictures, and also during the process. So this is where we started, boiler number 3. You can see the boiler water was complete black and a lot of iron inside. During inspection, we found these gunk balls, or so it's iron and organics all stick together with the FFA. So it's like a accumulation of impurities, and they could easily be removed. And you see after the last boil out, the water turns clear and without any turbidity inside. Also here, this is for boiler 1, so this is a different manufacturer. Boiler water was more brown, but also here after the boil out, it was much clear and in a very good state. Here's what the boiler looks like when it was delivered. So this it was filled with water. You can see all the rusty surfaces. So this picture is after the flush of the boiler, and after the cleaning, it looks much better, smoother surfaces. You can also see some magnetite forming. And on the second boiler, which the brown water inside, you can see it's not that rusty, but also you see those iron oxides on the tubes and also on the wall of the boiler shell. And we have some very good results after the cleaning. From the measurement results, we have a different plant also in New Zealand. This is a biomass facility, 30 megawatts power output. And you can see we started at a very high levels of turbidity and iron in the boiler water, and it drops down rapidly after injection of ODA, and gives a second short peak, and then it remains low. And this was also confirmed by this let's call it jaw test. So here it was very turbid, and then it goes down and down and down, and at the end it was very clear. And here you can also see this is the ODA concentration. So we went up a little bit too high in the beginning, but then go down and keep it like that, and it goes down, which is part of the absorption of the ODA on the surfaces. pH, you can see we always stay in a range of 8. So no high pH required for the cleaning, and conductivity also remains stable over the whole process. So very easy handling and application. This is a larger combined heat and power plant in Switzerland, a sugar mill. Was a drum type natural circulation boiler with 50 bar. Here we had to apply the boil out during the dry heating of the refractory. So they had external burners installed and heat up the system slow by slow with some heating or keeping the pressure for sufficient time, and then start again. We injected here directly in the drum because when we were coming on site, we saw that there were no injection points available. Everything was welded together, so we had to cut some pipes to make an injection point, and so we injected directly in the boiler drum. No phosphates, no other polyacrylates, and you can see on the pictures that we get a very clean and good surface on that treatment. To summarize this a little bit, so the standard procedures are the alkaline boil outs using trisodium phosphates, for example, and the FFA is the more modern way. So if you look at roll and mill scale, so the FFA starts to use this and incorporate that in the protective layer which is formed on top. oil and grease and iron deposits are removed, same as for the alkaline treatment. When you look at ecotoxicity, especially the phosphates have an high effect on that. Also, you need to use acids to control the pH when you discharge it to the environment. For FFA, you don't need that, so it's very low. Also, the wastewater management doesn't require a lot of effort for the FFA in comparison to the alkaline treatment. What is also very interesting is that you need much less chemicals to do a FFA treatment or FFA boil out compared to an alkaline boil out. The testing is very easy, so you check for the concentration and maybe the turbidity at the draining of the boiler water. And so the corrosion protection, and this is one of the major parts. If you do an alkaline boil out, you need to do something afterwards to keep control of corrosion in the boiler, because you have a wet surface. But with the FFA, you form already a protective layer. So where the FFAs are made for, so you can have a very efficient and safe alternative for the pre-commissioning cleaning of boilers. So that's all for today. If you want to have more information, please have a look at our download section. So you find all our articles about the use of film-forming amines, or have a look at our webinars. The recordings from the last year and also the first one from this year is already available on our website, so where you find more information. So thank you for today, for joining us, and would be happy to answer your questions. So please.
Hey, Ronnie. Thanks again. There was one question I received, which was about the application guidelines. You said best practices, which was about your 0.7, increase the water level inside the boiler to maximum level and keep concentration stable. And the question was step 7, after keeping boiler at 150 degrees during 8 hours. That was the question.
Yes, it's good to keep it the pressure and the temperature over at least 8 hours, just to make sure you have a good distribution of the amine through the whole boiler unit. Of course, if you have a very small boilers, you can reduce this, but from our experience, so 8 hours is a good schedule. And if the boiler is larger, you should better extend the period to 10 to 12 hours.
No further questions from the chat.
Thanks, Björn. So, anything else? No?
Wait, there's one more question from Zabelo. Zabelo raised her hand, so open the mic and ask your question.
Thank you. Can you please confirm if you can hear me?
Sorry, I didn't hear it.
Yeah, can you hear me?
Yes.
Okay, I just want to check the last case study. It's for the work that was done on a 5-bar boiler. I want to check if you have experiences with the high pressure boilers, say over 15 or 16 MPa. Do you have experiences?
So the last one was 50 bars.
Oh, it was 50 bar, yes.
Yeah.
Do you have experiences on boilers over, let's say, 16 MPa?
No, most of the boilers we've done are at 50 bar, 60 bar less. So this is most cases where we applied that. But yeah, I know that are a couple of applications across Europe, so which we were not, or which not we have done, but where also FFAs were used, and at also a higher pressure level.
Okay, thanks. My interest is on the thermal stability. I mean, if you can maybe indicate the thermal stability in terms of for your product, how stable is it at elevated temperatures? Say over basically for the high pressure boilers.
So so for the boiler, this is not a case because you don't get that high with the temperature. In general, the film-forming amines undergo a thermal degradation, which, depending on the used product, starts at 350, 400 degrees Celsius, and from there it starts to thermal degrade. But this is a little bit different topic, and so the risk is that under these conditions you form low weight organic acids, but these are mainly coming from the alkalizing amines, which are often in those formulations, and less from the filming amines. So that's why I was focusing on the filming amine, so the active component, and not on the product, because also in those products there are a lot of different mixtures and blends on the market, and you need to make sure what is the exact composition of the product, and how is it acting in the specific temperature range. So we prefer using pure products, so without any alkalizing or emulsifying agents in it, because then the effect on the cation conductivity, for example, is much less compared to these blends and mixtures.
Okay, thank you. Can I ask one last question?
Yeah, of course.
Yeah, I just want to check the impact of some of the FFA on the ion exchange resin. I think by now is widely understood. But for your product, have you looked at this? Can you maybe say this with certainty that there is no impact on the ion exchange resins if we were to use your product?
You always have an impact on the ion exchange resin. The main thing is that the if you have a condensate polisher, I think this is the questions you are asking for. Within a condensate polisher, during time you get an accumulation of the filming amine inside of the resin column, and so if the concentration gets too high, so the resin starts floating, you get a small portion of resin floating to the top, and at the same time the regeneration process is affected as well, because you have the density difference between the two resins, anion and cation exchange, it becomes more equal, so they are harder to separate, which is the main problem. But there are some, let's say, techniques, procedures available to make this effect less. But at the end, if you have a condensate polisher with a mixed bed resin, you need to have a close look, especially when you're applying film-forming amines. Doesn't matter which product, which type of amine, you will have an effect on the resin.
Yeah, but in terms of, let's say you're operating a separate bed, are you certain that for a separate bed, if you have the means to effectively separate the resins by regeneration alone, you will be able to recover the performance?
Yes, yes.
Oh,
But the regeneration process might become a bit more difficult.
okay. No, thank you very much.
You're welcome.
There was one more raised hand by Gazanfa, but I think he took that back. I'm not sure whether he still has a question. Oh yeah. So just open the mic and feel free to ask your question.
Hi, Ronnie. Can you hear me?
Yes, perfectly.
Yes. I have two questions. Number one, most of the example you have shown are related to boiler having pressures 50, 60 bar. Does your product is applicable for the high pressure boilers like maybe supercritical or critical like 90 bar, 100 bar or 100 plus bar? Is this applicable over there or not?
Yes, it is.
Secondly, it is applicable. Secondly, the cleaning procedure with the amines which you have discussed in the presentation, is this procedure recommended by any boiler manufacturer in Europe, in China, or in some other country or not? Because most of the boiler manufacturer, I'm from Pakistan, so in Pakistan there are a lot of Chinese boilers, and they always prefer to adopt the conventional boiler boiling procedure of using the sodium carbonate and TSP and dispersant. So, does your boil out procedure is recommended by any boiler manufacturer in the world?
No. There is no recommendation by boiler manufacturers to use film-forming amines, but plenty of them using them already. And also we have worked with some boiler manufacturers in the past, but at the end it's always a decision together with the end user, what can be used and what not. So a general recommendation doesn't exist.
And I know some information about the products, the amines which you are manufacturing. So these amines can be applicable for the high pressure boilers in a regular treatment program, like supercritical boilers having pressure more than 100 bar.
Yes. So yes, we have
Okay.
for preservation or also for a flex operation, they are applicable until 190 bar. So for now, we have no references with supercritical units, but until 190 bar, yes, we have.
Okay. Okay. Thank you.
No
Okay.
other. Well, there's one more.
Of course.
Zabelo again.
Yeah, I'm sorry about that. Yeah, I just want to check. I will be, this is my first webinar with you. I will be going through the other webinars. I see that you have recorded webinars, but I want to check. You said the minimum temperature for injection is 60 degrees Celsius.
Yes.
I did not get clearly what you said would be the impact if you are injecting at a temperature below 60 degrees Celsius.
Okay.
If you can maybe touch on that.
Yeah. So we recommend to do the injection at not below 60 degrees Celsius because of the solubility of the product in the water. So if you have so the saturation concentration at 2 ppm of product is around 20 degrees Celsius. But to avoid any overfeeding issues and any risk of depositing the product somewhere in the boiler surfaces, we recommend to use a higher temperature, or we recommend to inject at higher temperatures to make sure the product is good diluted and distributed through the whole system. So we don't want to make any clogging of piping, or this is also a little bit depending on the injection point. So if you're injecting directly in the drum, it is less important, but if you're injecting in smaller pipes, So temperature should be higher. So what is important that you avoid local overfeeding issues. So that's why we recommend a higher temperature, because then the solubility is much better in the system.
Okay, thank you for that. Maybe one last question. Can you confirm that you don't need any special injection nozzle for this specific product?
No, we don't need specific injection nozzles. We take, especially for this boil out, you have to take what you get. So, and sometimes we had to cut the lines for the pressure gauge just to make an injection point available. So in these cases, you need a little bit of flexible and look for the best place, because you also have to, it's not just injection place, it's also you need to place the pump somewhere, you need to store the chemicals somewhere. This all should not be that much away from each other. So yeah, this is a site-specific decision where you inject and how you inject. But a specific nozzle is not required.
Okay, no, thank you very much. I'll be going through your other webinars. Thank you.
Enjoy.
There's another question, Ronnie, from our friend, which is in Cyrillic, so I can't say the name. Just open the mic and ask a question. Most probably either it doesn't work or the question is no longer relevant. So then there is nothing else at the moment.
Okay, so thank you, everyone. Enjoy the rest of the day, and hopefully we will see us soon with the next webinar. So in the meantime, just look at our recordings, and if you find it interesting, just get in touch with us for further questions. Cheers, bye.